Have you ever get lost in a building?
Maps and GPS positioning have become an integral part of our lives, but they won't work inside of buildings. MapBiquitous wants to fill this gap by combining indoor and outdoor location-based systems. To present interactive floor plans integrated with a map, building data has to be provided. The building data is stored within a geographically distributed system of so-called building servers. Each building server represents a building and provides all necessary data for that building. Depending on the location of a user, appropriate building data is loaded from a different server. This setup naturally distributes user access and allows the creation of a globally scalable system. The building maps are projected directly onto the global map, so map and building appear to be integrated to the user. Furthermore, the building's data is stored floor-wise and is loaded if needed. In addition to every floor plan, layers for navigation and different positioning techniques are provided. In this way, the building model can easily be extended to support various positioning methods and in-building navigation. Building data is provided in geographic markup language, GML in short, an XML grammar standard language for geographical features. This makes it flexible and highly interoperable. This GML data is generated by a web feature service from vector data stored in a database for geodata. MapBiquitous uses the global WGS84 coordinate system, which can be referenced worldwide. This allows an easy mapping of map and building data. Usually, GPS is not available inside buildings. Therefore, additional techniques are necessary to determine the own position inside buildings. The most important is wireless LAN. It is possible to calculate the current position of a user by using the positions of the individual access points. All other methods can improve the accuracy. With a phone's accelerator sensors, steps made can be detected. By knowing the average step length of the user, the walking distance can be calculated. The orientation of the user can be determined with a compass or a gyroscope sensor. In this way, MapBiquitous can detect that the user changes his walking direction, for instance, if he walks around a corner. The current height can be determined by the phone's barometer. In this way, MapBiquitous can automatically detect the current floor level of the user. MapBiquitous also supports the navigation inside and between buildings. The building model contains a layer of waypoints for each floor, which can be used by the routing component of MapBiquitous to calculate paths inside buildings. A path between rooms of different buildings is a combination of a path from a room in a building to an entry door, an outdoor path between the buildings, and finally a path from the entry door of the second building to its target room. There are additional information of each room available, and the possibility to bookmark points of interest. MapBiquitous is able to collect information about changes of building data from its user with its built-in crowdsourcing module. It is, for example, possible to scan a barcode to recalibrate your current position. Corrected data extracted from the recalibration is then sent to the building server, validated and incorporated into the building data. Other users can then profit from this corrected information.